Before you start working with data in Databricks, there is one thing you need to understand first: the lakehouse architecture and how the Databricks platform is organized. Many candidates focus on commands and data processing but struggle on the exam because they miss these core concepts. In this complete study guide, we will cover all 6 sections of the Databricks Certified Data Engineer Associate exam, starting with the foundation of the Databricks Lakehouse platform. You will learn what a lakehouse is, why it has changed modern data engineering, and how the Databricks workspace is logically structured. These concepts are essential for understanding everything that comes next, so watch the complete video carefully. I have also included a free study guide with some of the most important exam questions in the description to help you prepare. And stay until the end, because I will share some simple and practical tips that can help you prepare for the certification exam and pass it with confidence. To understand the lakehouse, we first need to look at the traditional ways organizations have stored data, specifically data warehouses and data lakes. A data warehouse is highly structured, great for business intelligence, and optimized for fast queries, but it really struggles with raw or unstructured data. On the other hand, a data lake is essentially a massive, cheap storage dump for all types of data, but it lacks the reliability, structure, and speed needed for quick analytics. This historical separation forced companies to copy data back and forth between the two systems, creating a messy, expensive, and fragile data architecture. The Databricks Lakehouse platform solves this historical problem by combining the best features of both data warehouses and data lakes into a single, unified system. It provides the cheap, scalable storage of a data lake, while seamlessly overlaying the reliability, structure, and performance of a traditional data warehouse. This means data engineers, data scientists, and business analysts can all work comfortably on the exact same copy of the data. For your exam, remember that the lakehouse architecture eliminates data silos and removes the need to constantly move data between different storage systems. The magic engine that makes the Databricks Lakehouse possible is an open-source storage layer called Delta Lake. Delta Lake sits directly on top of your existing cloud storage, like Amazon S3 or Azure Data Lake, and brings much-needed structure to your raw data. When you save data as a Delta table, it is physically stored in an open format called Parquet, but Delta adds a crucial transactional log on top of it. This transaction log keeps track of every single change made to the data, which is exactly what allows Databricks to guarantee data accuracy and reliability. One of the most important concepts for your exam is that Delta Lake provides ACID transactions. ACID stands for atomicity, consistency, isolation, and durability, which is a fancy way of saying your data operations will never fail halfway through and leave your data corrupted. If you are updating a million rows of customer data and a server unexpectedly crashes, Delta Lake ensures that either all the rows are updated, or none of them are. This reliability guarantees that anyone reading the data will always see a consistent, accurate view, which was historically impossible in traditional data lakes. Because Delta Lake keeps a detailed transaction log of every change, it unlocks a powerful feature known as time travel. Time travel allows you to instantly query older versions of your data exactly as it looked at a specific point in the past. This is incredibly useful if you accidentally delete a table, or if a bad code deployment corrupts your data overnight. On the certification exam, if you see a question about auditing historical data, fixing accidental deletions, or reproducing a machine learning model, time travel is almost always the correct answer. Moving away from storage, you need to understand how the Databricks architecture is physically split into 2 main parts, known as the control plane and the data plane. The control plane is managed entirely by Databricks, and it handles the web application, notebook commands, cluster management, and workflow scheduling. The data plane is located entirely inside your own cloud account, meaning your actual data and the servers processing the data never leave your secure environment. This separation of powers is a massive selling point for Databricks because it ensures absolute data privacy and security for the customer. Whenever you want to run code or process data in Databricks, you need to spin up a compute cluster in the data plane. A cluster is simply a group of cloud servers, often referred to as nodes, that work together to execute your code across massive datasets. There is always one driver node that coordinates and manages the work, and multiple worker nodes that actually perform the heavy data lifting. Understanding how to choose the right cluster size and type is a common exam topic, as it directly impacts both the performance and the daily cost of your data engineering pipelines. Databricks provides two main types of compute clusters, which are all-purpose clusters and job clusters. All-purpose clusters are designed for interactive, collaborative development, meaning you spin them up when you are actively writing and testing code in a notebook. Job clusters, on the other hand, are created automatically by Databricks to run a specific automated pipeline, and they shut down immediately when the job is finished. For the exam, always remember that job clusters are significantly cheaper than all-purpose clusters, so you should exclusively use them for running automated, scheduled production workloads. The Databricks workspace is the web-based interface where you will spend almost all of your time as a data engineer. It is a unified environment that brings together your notebooks, compute clusters, data explorers, and workflow scheduling into one clean screen. You can logically organize your workspace using folders, manage user access permissions, and seamlessly collaborate with other team members in real time. The exam will expect you to know where certain administrative features live within this workspace, so getting very comfortable with the left navigation bar is a highly recommended study tip. Databricks notebooks are the primary tool you will use to write, test, and execute your daily data engineering code. A notebook is essentially a document that contains runnable cells of code, allowing you to build your logic step by step while seeing the output immediately below. One of the best features of Databricks notebooks is that they are polyglot, meaning you can write Python, SQL, Scala, and R all within the exact same document. This ultimate flexibility allows you to easily use the best language for the specific task at hand. To switch languages inside a notebook, you use special instructions called magic commands, which tell a notebook cell to behave differently than the default language. For example, if your notebook is set to Python, but you want to write a quick SQL query, you simply type %SQL at the very top of that specific cell. Another incredibly useful magic command is %run, which allows you to execute an entirely different notebook from within your current working notebook. You will definitely see questions about magic commands on the certification exam, especially regarding how to seamlessly switch between Python and SQL. The Databricks file system, commonly known as DBFS, is a virtual file system that comes pre-installed in every single Databricks workspace. DBFS essentially maps the complex cloud storage URLs of your cloud provider into a simplified, easy-to-read folder structure. This means you can interact with your massive cloud storage buckets using familiar file paths, just like you would on your personal home computer. While DBFS is great for quick experiments and storing library files, Databricks now recommends using Unity Catalog for enterprise data governance, which we will cover in a later section. As a data engineer, version control is an absolute requirement, and Databricks provides a feature called Git folders to easily handle this. Git folders allow you to connect your Databricks workspace directly to Git providers like GitHub, GitLab, or Azure DevOps. This means you can pull code from a repository, make necessary changes in a Databricks notebook, and immediately push those changes back to version control without ever leaving the workspace. Understanding how to integrate Git for continuous integration and continuous deployment is a heavily tested skill on the Data Engineer Associate exam. As we talk about structuring data in the lakehouse, we absolutely must discuss the medallion architecture, which is a core Databricks design pattern. The medallion architecture logically organizes your data into three distinct layers, naturally named bronze, silver, and gold, representing the quality and readiness of the data. The primary goal is to incrementally improve the structure and cleanliness of your data as it flows sequentially from one layer to the next. This organized pipeline approach is the modern industry standard for building robust data lakes, and it is heavily emphasized on the certification exam. The first layer in the medallion architecture is the bronze layer, which acts as the raw ingestion point for all of your incoming data. In the bronze layer, data is stored exactly as it arrived from the source systems, meaning it might be messy, duplicated, or missing values entirely. You should never apply any complex transformations or business logic here, because the bronze layer serves as a pure historical archive of the original data. If you ever find a critical bug in your downstream logic, you can always go safely back to the bronze layer to reprocess the raw data from scratch. The middle layer is the silver layer, and this is truly where the heavy lifting of data engineering actually happens. In the silver layer, data from the bronze layer is thoroughly cleaned, filtered, deduplicated, and transformed into a standardized enterprise format. This layer provides a refined, unified view of your data, making it completely ready for self-service analytics and ad hoc querying by data scientists. For the exam, closely remember that the silver layer focuses heavily on data quality and integration, merging multiple raw data sources into reliable, trustworthy tables. The final destination in the medallion architecture is the gold layer, which contains highly refined, business-level aggregates. Data in the gold layer is specifically tailored to easily answer specific business questions, power reporting dashboards, and feed advanced machine learning models. Instead of raw customer transactions, the gold layer might contain a table showing total weekly sales per region, completely optimized for fast reading. When business analysts use Databricks SQL to build their reports, they are almost exclusively querying the pristine data currently sitting in the gold layer. To summarize this foundational knowledge, the Databricks Lakehouse platform is specially built to unify your entire data ecosystem using the power of Delta Lake. You learned that Delta Lake provides vital ACID transactions and time travel, ensuring your data is always perfectly reliable and safely recoverable. We also thoroughly explored the workspace, compute clusters, notebooks, and the highly important bronze, silver, and gold medallion architecture. Mastering these exact core concepts is your first major step toward passing the Databricks Certified Data Engineer Associate exam, as they form the backbone of everything else we will cover. Congratulations on successfully completing the first section of this certification course. You have already made fantastic progress today. Now that you strongly understand the Lakehouse platform, I highly encourage you to immediately complete the attached practice test for this section. Practice questions are the absolute best way to improve your memory retention, verify your understanding, and quickly get a feel for real exam scenarios. The practice test is included right here with this lesson, so please take a few minutes to actively test your new knowledge. Once you are finished, I look forward to seeing you in the next section, where we will start processing real data using Apache Spark. Welcome back to the second section of our course, where we are going to master Apache Spark, the incredibly powerful processing engine that drives the Databricks platform. In this lesson, you will learn how to extract raw data, transform it using Spark SQL and data frames, and load it safely back into your lakehouse. Understanding how to manipulate massive datasets efficiently is the absolute core of a data engineer's daily job, making this topic critically important. Get ready to learn the real mechanics of big data processing, because mastering these concepts will make a massive portion of the certification exam feel incredibly easy. To begin, we need to understand exactly what Apache Spark is and why it is so famous in the data engineering world. Spark is an open-source, distributed compute engine designed specifically to process massive amounts of data at lightning speed. Instead of trying to process a massive file on one giant, expensive computer, Spark takes that file, breaks it into thousands of tiny pieces, and processes them simultaneously across many smaller, cheaper computers. This distributed approach is what allows modern companies to process terabytes of data in minutes rather than days. When you run code in Databricks, Spark uses a very specific manager and worker architecture to get the job done. The central manager is called the driver node, and its only job is to read your code, figure out the best way to execute it, and assign tasks to the team. The actual heavy lifting is done by the worker nodes, which process the raw data in parallel and report back to the driver when they are finished. For the exam, always remember that the driver plans and coordinates, while the worker nodes execute the physical data processing tasks. The primary way you will interact with your data in Spark is by using a structure called a data frame. A data frame is simply a large table with organized rows and named columns, looking very much like an everyday Excel spreadsheet or a traditional SQL database table. By organizing complex, messy big data into this highly structured tabular format, data frames make reading, cleaning, and analyzing information incredibly intuitive. You will spend the vast majority of your career as a data engineer writing code that manipulates these data frames. One of the best things about Databricks is that you have two completely interchangeable ways to work with data frames. You can write your logic using standard SQL, which is perfect if you come from a traditional database background, or you can use PySpark, which uses the Python programming language. Behind the scenes, the Spark engine treats both SQL and PySpark exactly the same, automatically translating them into identical performance plans. The certification exam expects you to be somewhat comfortable reading both syntaxes, as they are both heavily used in modern data teams. Before we write any data, we need to talk about ELT, which is the modern paradigm Databricks strongly promotes over traditional ETL. ELT stands for extract, load, and transform, which means you extract raw data from the source and load it directly into the bronze layer of your lakehouse without changing it first. Once the raw data is safely loaded into the cheap storage of the lakehouse, you use the massive power of Spark compute clusters to transform it. This pattern is heavily tested on the exam because it is much more scalable and resilient than transforming data on a fragile, external server before it reaches the lake. The first step in any data pipeline is extraction, and Spark makes reading data incredibly simple. Using the Spark read command in your notebook, you can easily pull data from almost any format imaginable, including CSV files, JSON documents, or external databases. Spark will automatically scan the file, figure out what the columns and data types should be, and instantly display it to you as a clean data frame. This built-in flexibility means you can ingest data from dozens of different company systems without needing specialized third-party tools. Once you have read and transformed your data, the next step is to load it back out to storage using the Spark write command. You can save your data frames into many different file formats, but this is a critical point for the certification exam. You must always remember that the default, heavily recommended, and most optimized format for writing data inside Databricks is Delta. Writing data as a Delta table automatically gives you all the powerful features we discussed in the last section, like ACID transactions and time travel. A massive concept that is guaranteed to appear on your exam is the fundamental difference between transformations and actions in Spark. Transformations are simple instructions you give to Spark, like telling it to filter out old dates, drop empty columns, or rename a specific header. When you type a transformation, Spark is actually lazy, meaning it just quickly writes down your instruction in a notebook, but refuses to physically do the work yet. Spark prefers to gather up all of your instructions first so it can figure out the most efficient, streamlined way to perform them all at once. The only way to force Spark to stop being lazy and actually execute your code is by triggering an action. Actions are commands that require Spark to produce a final, physical result, such as displaying the data on the screen, counting the total number of rows, or saving the data to storage. The moment you call an action, Spark looks at all the lazy transformations it collected, creates a highly optimized execution plan, and sends the work out to the worker nodes. This lazy evaluation process is exactly what makes Spark so incredibly fast and resource efficient. Let us look at the most common transformations you will write, starting with selecting and filtering data. Selecting is simply choosing which specific columns you want to keep from a massive dataset, allowing you to ignore irrelevant information and speed up processing. Filtering is the act of keeping only the specific rows that meet a certain condition, such as only keeping customers who live in Canada. These basic operations are the very first steps in taking messy bronze layer data and turning it into clean silver layer tables. Another critically important transformation is aggregation, which is how you summarize massive datasets into useful business metrics. Using group by commands, you can easily calculate things like the total sum of sales per region, the average salary per department, or the maximum temperature per month. Aggregations require Spark to shuffle data around between different worker nodes to calculate the final totals, which can sometimes slow down performance if the datasets are gigantic. Understanding how to group and aggregate data is a foundational skill for building those highly refined gold layer reporting tables. Real-world data is almost never perfect, so knowing how to handle missing or corrupt values is an essential data engineering skill. Spark provides very easy built-in functions that allow you to simply drop any rows containing null or empty values with a single line of code. Alternatively, instead of dropping data, you can choose to automatically fill those blank spaces with a sensible default value, like replacing a blank price with a 0. You can expect the exam to present scenarios where you must choose the most logical way to clean up missing information. In almost every pipeline, you will eventually need to combine information that lives in two completely separate tables, which is known as a join. For example, you might have one data frame containing customer purchases and a completely different data frame containing the customer shipping addresses. By joining them together using a common column like the customer ID, you create one massive, incredibly useful table. Spark supports all the standard SQL joins you might already know, such as inner joins, left joins, and outer joins, making data integration very straightforward. While Spark has hundreds of amazing built-in functions, sometimes you need to apply very specific, unique business logic that Spark simply does not have. To solve this, you can write a user-defined function, commonly called a UDF, using standard Python code, and then apply that custom function directly to your data frame columns. UDFs give you unlimited flexibility to write any complex mathematical calculation or text manipulation your business requires. However, you must be very careful when using them in a production environment. The certification exam heavily tests your understanding of the performance penalties associated with Python UDFs. Because Spark is written in a language called Scala, running a Python UDF forces Spark to serialize and translate the data back and forth between languages for every single row. This completely bypasses Spark's optimized execution engine and can make your data pipeline run incredibly slowly. As a strict rule for the exam and real life, you should always try to use native, built-in Spark functions first, and only write a custom Python UDF as an absolute last resort. Whenever you run an action and trigger a Spark job, you can deeply monitor its progress using a built-in tool called the Spark UI. The Spark UI is a graphical interface available directly inside your Databricks workspace that shows you exactly what your compute cluster is doing under the hood. It visually displays the execution plan, shows you how long each individual task is taking, and helps you easily identify where your code might be getting stuck. While you will not be asked to memorize the UI for the exam, knowing that it is the primary tool for troubleshooting performance bottlenecks is important. To squeeze the maximum possible performance out of your queries, Spark utilizes a concept called partitioning when saving data to storage. Partitioning physically divides a massive dataset into smaller, separate folders based on a specific column, such as creating a separate folder for every single year of sales data. When a user queries the data and asks for the year 2025, Spark is smart enough to completely ignore all the other folders and only read the specific 2025 directory. This concept, known as partition pruning, drastically reduces the amount of data Spark has to read, resulting in incredibly fast queries. To summarize this section, you now have a solid understanding of how Apache Spark uses a distributed driver and worker architecture to process massive amounts of data. You learned the fundamental differences between lazy transformations and execution triggering actions, which is a major concept for the exam. You also know how to read raw data, apply filters and joins using data frames, and safely write the data back as highly optimized delta tables. These are the exact, everyday ELT skills you will use to physically construct the medallion architecture pipelines we discussed earlier. Congratulations on finishing the second section. You are doing a phenomenal job grasping these core data engineering concepts. Now that you understand the mechanics of Spark and data frames, I highly encourage you to jump into the attached practice test for this section. Answering practice questions right now will rapidly improve your attention and prepare you perfectly for the tricky ways the exam might ask about transformations and actions. This test is completely included with your lesson, so please take advantage of this active learning opportunity. End this section strong, and I cannot wait to see you in the next section where we will tackle the exciting world of continuous streaming data. Welcome back to the third section of our Databricks Certified Data Engineer Associate Exam Preparation course, where we will transition from traditional batch processing into the dynamic world of continuous data. In this lesson, you will learn how to handle data that never stops arriving by using Spark structured streaming and the incredibly powerful Databricks autoloader. Understanding how to process new files incrementally the moment they arrive is absolutely crucial, because modern businesses demand real-time insights, not yesterday's news. Get ready to level up your engineering skills, because by the end of this video, you will be fully equipped to build highly responsive, continuous data pipelines that are heavily featured on the certification exam. To truly appreciate streaming, we first need to quickly contrast it with the traditional batch processing we learned in the previous section. In a batch process, you typically schedule a job to run once a day, waking up a cluster to process a massive, static chunk of data all at once before shutting down. While batch processing is great for historical analysis, it means your business reports are always at least one day out of date. Streaming data, however, is a continuous flow of new information, like live website clicks or credit card transactions, that must be processed immediately as it happens. Databricks handles this continuous flow using an engine called Spark Structured Streaming, which is built directly on top of the Spark SQL engine you already know. The brilliance of structured streaming is that it treats a live data stream exactly like a normal, continuously growing data frame. This means you do not have to learn a completely new programming language or complex set of commands to work with streaming data. You can simply take the exact same data frame transformations, filters, and aggregations you learned in the last section and apply them directly to a never-ending stream. The code required to switch from batch to streaming is wonderfully simple, requiring just a tiny change in your standard syntax. Instead of using the normal Spark read command, you simply use Spark read stream to tell the engine to keep the connection open and listen for new data. Similarly, when it is time to save your processed data, you swap out the traditional write command for Spark write stream. This tiny vocabulary change unlocks the massive power of continuous processing, and recognizing these specific keywords is a guaranteed way to score easy points on the exam. Behind the scenes, Spark Structured Streaming actually uses a clever technique known as micro-batching to achieve its impressive real-time performance. Instead of processing every single individual row, the exact millisecond it arrives, Spark gathers incoming data into tiny, rapid-fire batches that process every few seconds. This micro-batch approach provides the perfect balance between high-speed real-time processing and the massive scalability required to handle millions of records per minute. For the exam, just remember that structured streaming is essentially running very tiny, continuous batch jobs extremely quickly under the hood. You have absolute control over how often these micro-batches run by configuring a very important setting known as a trigger. A trigger defines the exact timing of your streaming pipeline, telling Spark whether it should look for new data every 10 seconds, every 5 minutes, or even just once a day. If you do not specify a trigger, Spark will default to processing new data immediately after the previous micro-batch finishes, running as fast as the hardware allows. Understanding how to configure triggers allows you to perfectly balance your desired data freshness with your monthly cloud computing costs. There is one highly specific trigger setting you must memorize for the certification exam, and that is called Trigger Available Now. When you use Trigger Available Now, Spark will quickly wake up, process all the new data that has arrived since the last run, and then completely shut down the cluster. This essentially turns your streaming pipeline into a highly efficient batch job that automatically remembers exactly where it left off yesterday. The exam loves testing this concept because it is the most cost-effective way to incrementally process daily files without paying for a cluster that runs 24 hours a day. The magic that allows structured streaming to always remember where it left off is a critical feature known as checkpointing. Whenever a streaming job runs, it constantly saves its current progress, including exactly which files it has already read, into a special hidden folder called a checkpoint location. If your compute cluster unexpectedly crashes or you intentionally turn it off for the weekend, the checkpoint guarantees that absolutely zero data is lost or processed twice. You can confidently expect the exam to ask how streaming jobs recover from failure, and checkpointing is always the correct answer. When you are writing streaming data to a final destination, you must specify an output mode, which tells Spark exactly how to update the target table. The most common mode is append, which simply takes the brand new incoming rows and adds them safely to the very bottom of your existing table. Another common option is complete mode, which forces Spark to completely overwrite the entire target table with a fresh, recalculated dataset every single time the micro-batch runs. Knowing the difference between append mode for simple inserts and complete mode for full aggregations is a very common exam scenario. Speaking of aggregations, summarizing data over time is incredibly common in streaming, such as calculating the total number of website visitors every 5 minutes. However, because streaming data never stops, maintaining a running total forever would eventually crash the memory of your compute cluster. To solve this, Spark requires you to use watermarking whenever you perform aggregations on a continuous stream. Watermarking is simply a clever rule that tells Spark it is safe to throw away old, historical data from memory once it becomes too old to matter anymore. Now that we understand the core mechanics of streaming, we must discuss the absolute best way to ingest raw cloud files, which is a Databricks feature called Autoloader. Autoloader acts like an incredibly smart, highly automated watchtower that constantly monitors your cloud storage buckets for any newly arriving files. As soon as a new CSV or JSON file drops into your Amazon S3 or Azure bucket, Autoloader immediately grabs it, processes it incrementally, and loads it into your bronze layer. Autoloader is the modern, highly recommended replacement for writing complex custom ingestion scripts, making it a major focus of the certification exam. Using Autoloader in your code is brilliantly simple, as it just requires you to specify a special data format called cloud files. When you write your Spark read stream command, you simply set the format to cloud files, and Databricks automatically handles all the complex file tracking behind the scenes. This built-in integration makes Autoloader completely seamless to use alongside the standard structured streaming concepts you just learned. The exam will definitely check if you know that the keyword cloud files is the exact trigger to activate Autoloader ingestion. Autoloader discovers new files using two different underlying methods, which are directory listing and file notifications. Directory listing is the default method, where Autoloader simply scans your storage folder repeatedly to see if anything new has appeared, which works perfectly for folders with fewer files. However, if your folder contains millions of historical files, scanning it repeatedly becomes incredibly slow and expensive. When the exam asks how to ingest massive directories efficiently, the answer is configuring Autoloader to use the highly scalable file notification method instead. One of the biggest challenges in data engineering is dealing with raw data files that constantly change their shape or structure. Thankfully, Autoloader has a fantastic feature called schema inference, which automatically figures out the correct column names and data types of your incoming files. This means you do not have to manually type out a massive, complex schema definition every time a new data source is added to your pipeline. Schema inference saves countless hours of development time and is a highly celebrated feature that Databricks loves to test candidates on. Even better than inferring the initial schema, Autoloader also gracefully handles the nightmare scenario of schema evolution over time. Imagine your data provider suddenly adds 3 completely new columns to their daily JSON files without warning you beforehand. Instead of crashing your pipeline and throwing a massive error, Autoloader can automatically detect these new columns, update the target delta table, and safely load the new data. Understanding that Autoloader prevents pipeline failures by automatically evolving schemas is a critical concept for passing your certification. Sometimes, incoming data is so completely broken or formatted incorrectly that even Autoloader cannot figure out how to pass it into the correct columns. Instead of failing the job or quietly throwing the bad data away, Autoloader saves the day using a feature called the rescued data column. The rescued data column safely catches and stores any unparsable data as a raw string, allowing you to investigate and fix the problem later without losing a single record. The exam will absolutely ask how Databricks prevents data loss during messy ingestions, so always remember the rescued data column. Just like standard structured streaming, Autoloader heavily relies on checkpointing to guarantee data accuracy and reliability. By keeping a strict internal log of exactly which files have been successfully processed, Autoloader guarantees exactly once processing for every single file. This means even if you restart your pipeline 100 times, a specific file will never be accidentally loaded twice, completely eliminating the risk of duplicated data. This ironclad guarantee of exactly once processing is the primary reason Autoloader is the industry standard for bronze layer ingestion. It is highly important to realize that just because you ingest data using a stream, you do not have to use streaming for the entire rest of your pipeline. A very common medallion architecture pattern is to use Autoloader to continuously stream raw data into the bronze layer as quickly as possible. Then, you can use traditional, scheduled batch jobs to clean that data into the silver layer and summarize it for the gold layer later in the day. The exam wants to ensure you know that mixing continuous streaming and scheduled batch processing within the same lakehouse is a perfectly valid and highly encouraged strategy. To quickly summarize this dense but exciting topic, you have now mastered the mechanics of incremental processing using Spark structured streaming. You learned how checkpoints guarantee fault tolerance, how triggers control your processing frequency, and how micro-batches handle continuous data at scale. You also discovered Autoloader, the incredible tool that uses the cloud files format to automatically ingest files, infer schemas, and rescue broken data without breaking a sweat. These exact concepts form the absolute core of modern data ingestion, and mastering them is a massive leap forward in your certification journey. Congratulations on completing the third section of this course. You have officially learned how to handle real-time, continuous data pipelines like a true professional. Now that you understand the power of structured streaming and autoloader, I strongly encourage you to complete the attached practice test for this specific section. Answering these practice questions will lock these concepts into your long-term memory and perfectly prepare you for the tricky scenarios you will face on the real exam. The practice test is included right here with this lesson, so please take a moment to actively validate your new skills. End this section on a high note, and I will see you in the next lesson where we simplify all of this using Delta Live tables. Welcome back to the fourth section of our course, where we explore the incredible automation power of Delta Live tables. In this lesson, you will learn how to build reliable data pipelines without having to manually manage infrastructure or task dependencies. Understanding Delta Live tables is massively important because it represents the modern, highly recommended way to implement the medallion architecture on Databricks. Get ready, because this framework will completely change the way you think about data engineering, and it is a massive focus area on your certification exam. To understand why Delta Live tables, commonly called DLT, is so revolutionary, we need to talk about declarative programming. Historically, data engineers wrote imperative code, which meant manually typing out every single step of how a pipeline should run, including how to handle errors, manage clusters, and schedule tasks. DLT introduces a declarative approach, meaning you simply tell Databricks what your final data should look like, and the engine automatically figures out the most efficient way to build it. This shift from writing complex instructions to simply defining your end goals saves countless hours of coding and debugging. When you build a pipeline using traditional notebooks, you usually have to manually link them together and tell the system exactly which notebook should run first. Delta Live tables completely eliminates this tedious work by automatically understanding the relationships between your tables. If you create a silver table that reads from a bronze table, DLT instantly recognizes the connection and guarantees the bronze table will always be processed first. For the exam, remember that automatic dependency management is one of the absolute biggest benefits of using Delta Live tables. Writing code in Delta Live tables is incredibly straightforward because it perfectly supports both SQL and Python, just like standard Databricks notebooks. However, there are a few special keywords and decorators you must use to tell the engine that you are building a DLT pipeline. If you are writing in SQL, you simply add the word live in front of your standard table creation commands, which tells the system to manage that table automatically. If you prefer Python, you achieve the exact same result by placing a special @ DLT.table decorator directly above your data frame functions. Once you define your live tables, Databricks automatically generates a visual map of your entire data pipeline, which is formally known as a directed acyclic graph, or DAG. The DAG is a beautiful, interactive diagram that shows exactly how data flows from your raw sources all the way through to your highly refined gold tables. This visual interface makes it incredibly easy for data teams to monitor pipeline health, track where data is coming from, and quickly identify any bottlenecks. The certification exam will definitely expect you to know that DLT automatically generates this DAG to visualize your data lineage. One of the most heavily tested and critically important features of Delta Live tables is its built-in data quality management system, known as expectations. Expectations allow you to define strict data quality rules directly alongside your pipeline code, acting as automated bounces that check every single row of incoming data. For example, you can easily write an expectation that guarantees a customer age column must always be greater than 0. Instead of writing complex, separate testing scripts, these data quality rules are completely integrated into the natural flow of your DLT pipeline. There are 3 specific ways you can tell an expectation to handle bad data, and you absolutely must memorize them for the exam. The first option is simply called expect, which is the most lenient setting. When you use the standard expect rule, Databricks will catch the invalid rows, record a warning in the system logs, but it will still allow the bad data to flow into your final table. This option is great when you just want to monitor data quality trends without actually stopping or changing the data flow. The second data quality option is called expect or drop, which is exactly what it sounds like. If a row of data violates your predefined rule, the system will quietly throw that specific row away and only load the perfectly clean data into your target table. This is incredibly useful for filtering out completely useless records, like empty sensor readings or corrupted web clicks, before they can pollute your downstream dashboards. The exam will definitely ask you how to automatically filter out bad records in DLT, and expect or drop is the exact answer. The third and most strict data quality option is called expect or fail, which is designed to protect your most critical financial or medical data. If even a single row of data violates an expect or fail rule, Delta Live tables will immediately stop processing and completely shut down the entire pipeline. This aggressive approach guarantees that no bad data ever reaches your stakeholders, forcing the engineering team to immediately investigate and fix the root cause. Knowing when to use expect or drop, and expect or fail is essentially guaranteed to appear on your certification test. Whenever your expectations process data, DLT automatically records the results in a centralized location called the event log. The event log acts as a massive, automated diary that tracks exactly how many rows passed your quality checks and how many rows failed over time. By simply querying this log, you can easily build beautiful data quality dashboards to prove to your business stakeholders that the data is trustworthy. The exam might ask how to monitor data quality metrics in DLT, so always remember that the event log holds all of those answers. Delta Live Tables pipelines can be run in two entirely different execution modes, known as triggered and continuous. When you run a pipeline in triggered mode, it spins up a cluster, processes all the new data that is currently available, updates the tables, and then completely turns off. This is essentially a modern, highly optimized batch job that saves you a massive amount of money on compute costs. For the vast majority of business use cases that only need data updated once a day or once an hour, triggered mode is the perfect, cost-effective choice. On the other hand, running a pipeline in continuous mode tells Databricks to keep the compute cluster running 24 hours a day, 7 days a week. In this mode, the pipeline constantly listens for new data and instantly processes it the exact second it arrives, creating a true real-time streaming architecture. While continuous mode provides the absolute freshest data possible, it is significantly more expensive because you are paying for cloud compute every single minute of the month. The exam loves testing your ability to choose triggered mode for cost savings and continuous mode for strictly real-time requirements. Another brilliant feature you need to understand is how DLT handles pipeline environments using development and production modes. When you create a pipeline, you can easily toggle it into development mode while you are actively writing and testing your code. Development mode intentionally keeps the compute cluster running even after a pipeline fails, allowing you to quickly fix errors and instantly rerun the code without waiting for a new cluster to start. It also turns off automatic retries, so if your code is broken, it fails immediately rather than wasting time trying again. Once your code is thoroughly tested and completely ready for the real world, you simply switch the pipeline over to production mode. Production mode is specifically designed for stability and resilience, meaning it will automatically retry tasks if a random cloud error occurs. Furthermore, production mode will automatically shut down the cluster the moment the job finishes or fails, ensuring you do not waste money on idle servers. The certification exam expects you to know that development mode speeds up coding, while production mode maximizes stability and cost efficiency. We talked about Autoloader in the previous section, and it is important to know that Autoloader works perfectly inside Delta Live Tables. In fact, combining Autoloader with DLT is the absolute most recommended way to build the bronze ingestion layer of your medallion architecture. You can simply write a live table definition that uses the cloud files format, and DLT will automatically manage the continuous file ingestion alongside your data quality expectations. This powerful combination handles schema evolution, messy data, and pipeline dependencies all at the exact same time. One of the most historically difficult tasks in data engineering is managing database updates, specifically change data capture, or CDC. If a customer changes their home address, you have to carefully write complex code to find their old record, update it, and ensure you do not accidentally create duplicate entries. Delta Live Tables completely solves this massive headache with a single command called apply changes inter. This powerful feature automatically handles all the complex logic of updating, inserting, or deleting records based on incoming change events. The apply changes into command easily supports multiple data tracking methods, including what the industry calls slowly changing dimensions type 1 and type 2. Type 1 simply overwrites the old address with the new address, meaning you only ever see the customer's current state. Type 2 actually preserves the entire history, keeping the old address on file while marking the new address as the active one. The exam will verify that you know apply changes into is the specialized DLT command used to easily process change data capture and manage historical records. As you prepare for the exam, it is helpful to remember that Delta Live Tables is not a new programming language, but rather a powerful management wrapper around the Spark you already know. You are still writing standard SQL or PySpark code, but DLT takes over all the boring, frustrating parts of pipeline management. It handles the infrastructure, automates the dependencies, enforces data quality, and provides seamless switching between batch and streaming modes. Understanding this broader philosophy will help you answer situational exam questions about why a company should adopt the DLT framework. To summarize this incredibly important section, you learned that Delta Live Tables is a declarative framework that automates pipeline dependencies and generates visual data flows. You mastered the 3 data quality expectations, which are expect or drop, and expect or fail, and learned how they protect your downstream tables. We also explored triggered versus continuous execution modes, development versus production environments, and the magic of apply changes into for handling tricky database updates. These concepts represent the cutting edge of data engineering on Databricks, making them high-priority topics for your exam. Congratulations on completing the 4th section of this course. You are doing absolutely incredible work and getting so close to your certification goal. Now that you understand the immense power of Delta Live Tables, I highly encourage you to immediately complete the attached practice test for this section. Practice questions are the proven best way to improve your retention and get comfortable with how the exam will ask about data expectations and pipeline modes. The practice test is included completely free with this lesson, so please take advantage of this active learning step. End this section with confidence, and I will see you in the next lesson where we will master Unity Catalog and data security. Welcome back to the 5th section of our Databricks Certified Data Engineer Associate Exam Preparation course, where we dive into the highly important world of data governance. In this lesson, you will learn how to secure your data, manage user permissions, and track data lineage using Unity Catalog. Security is an absolutely massive part of modern data engineering, and understanding how to protect sensitive information is a critical requirement for passing the exam. Get ready to master the centralized governance model, because by the end of this video, you will confidently know how to secure an entire lakehouse architecture. To truly understand why Unity Catalog is so revolutionary, we first need to look at how Databricks managed data in the past. Historically, every single Databricks workspace had its own separate data catalog, known as a Hive metastore, which kept track of tables and permissions. This meant if your company had 5 different workspaces for different teams, you had to manually recreate access rules 5 different times. This decentralized approach was incredibly frustrating for security teams, prone to human error, and made enterprise-wide governance practically impossible. Unity Catalog solves this massive headache by providing a single, centralized governance solution that spans across all of your Databricks workspaces. Instead of managing permissions in isolated silos, you define your security rules once in Unity Catalog, and those rules automatically apply everywhere. If you grant a data scientist access to a specific table, they will instantly have that access regardless of which workspace they log into. The certification exam will definitely expect you to know that Unity Catalog provides this seamless, cross-workspace centralized governance. One of the biggest changes Unity Catalog introduces, and a heavily tested topic on the exam, is the 3-level namespace for referencing data. In older Databricks systems, you only used a 2-level namespace, writing queries that looked like schemaname.tablename. Unity Catalog adds a brand new top layer, meaning your SQL queries must now be written as catalogname.schemaname.tablename. Memorizing this exact 3-level structure is absolutely essential, as you will definitely see multiple choice questions trying to trick you with the old format. The top layer of this new structure is the catalog, which serves as the largest organizational bucket for your data assets. Catalogs are typically used to completely separate different business environments, such as having one catalog for development and a completely separate catalog for production. By separating data at the catalog level, you guarantee that a developer cannot accidentally delete or modify real production data while testing new code. For the exam, just remember that the catalog is always the very first word in the three-level namespace. The second layer of the namespace is the schema, which you might also hear referred to as a database in traditional SQL terms. A schema is simply a logical folder used to organize related tables and views within a specific catalog. For example, inside your production catalog, you might have one schema for marketing data, another schema for finance data, and a third schema for human resources. Schemas make it incredibly easy to manage permissions for entire departments, allowing you to grant access to an entire folder of tables all at once. The third and final layer of the namespace contains the actual tables and views, which is where your physical data actually lives. When creating tables in Unity Catalog, you have two entirely different options to choose from, which are managed tables and external tables. Understanding the fundamental differences between managed and external tables is one of the most frequently tested concepts on the entire Data Engineer Associate exam. You must know exactly how they handle file storage and what happens when they are deleted. A managed table is the default option in Unity Catalog, meaning Databricks handles everything about how and where the data is stored. When you create a managed table, the underlying Parquet files are stored in a dedicated cloud storage location that Databricks controls on your behalf. The most important detail to remember for the exam is that if you drop a managed table using a SQL command, both the metadata and the underlying data files are completely deleted forever. You should use managed tables when you want Databricks to fully automate the lifecycle of your data. An external table, on the other hand, allows you to keep the data files exactly where they currently live in your own specific cloud storage buckets. With an external table, Unity Catalog only manages the metadata, like the column names and access permissions, but it does not own the physical files. Because of this, if you drop an external table, Unity Catalog only deletes the metadata, while your actual raw data files remain perfectly safe in your cloud storage. The exam loves to test this distinction, so always remember that dropping an external table never deletes the underlying files. Managing user permissions in Unity Catalog is wonderfully simple because it uses standard SQL grant and revoke commands that you likely already know. If you want to give a user the ability to read a table, you simply write grant select on table, followed by the table name and the username. This standardization means you do not have to learn a complex, proprietary security language just to manage your Databricks environment. Knowing how to read basic SQL permission statements will help you quickly identify the correct answers on security-related exam questions. Sometimes, granting access to an entire table is too broad, especially when dealing with sensitive information like social security numbers or home addresses. To solve this, Unity Catalog supports dynamic views, which allow you to easily implement row-level and column-level security based on who is running the query. You can write a SQL view that checks the current user's identity and automatically masks out sensitive columns or hides specific rows they are not allowed to see. The exam will expect you to know that dynamic views are the standard way to protect personally identifiable information, commonly known as PII. When Unity Catalog needs to read files directly from your cloud storage, it does so using a highly secure feature called storage credentials. In the old days, developers would often dangerously hardcode cloud access keys directly into their notebooks, which was a massive security risk. A storage credential completely fixes this by safely storing the cloud provider identity, like an Amazon IAM role or an Azure Service Principal, directly inside Unity Catalog. This means the engine can securely authenticate with your cloud storage without any developer ever seeing a secret password. Building upon storage credentials, the next concept you absolutely must know for the exam is called an external location. An external location is a Unity Catalog object that takes a specific cloud storage path, like an S3 bucket URL, and glues it together with a storage credential. Once you create an external location, you can easily grant specific users the permission to read or write files to that exact cloud bucket using standard SQL. The certification exam frequently asks how to securely connect Databricks to cloud storage, and the combination of storage credentials and external locations is the exact answer. Another incredibly powerful feature of Unity Catalog that requires absolutely zero setup is automated data lineage. Data lineage is the ability to visually track exactly where a piece of data came from, what transformations were applied to it, and where it eventually went. Every time you run a query, Unity Catalog silently records this flow in the background, creating a beautiful interactive graph that traces data from the bronze layer all the way to the gold layer. This is heavily tested on the exam because lineage is vital for troubleshooting broken dashboards and proving data trustworthiness to auditors. Not only does Unity Catalog track lineage at the table level, but it is actually smart enough to track lineage down to the specific column level. This means if you have a massive final report with a single incorrect number, you can click on that specific column and trace it all the way back to the exact raw file it came from. Column-level lineage takes the guesswork out of debugging complex pipelines, saving data engineers countless hours of painful investigation. The exam will definitely verify that you know Unity Catalog supports lineage at both the table and column levels. For security and compliance purposes, Unity Catalog also automatically captures detailed audit logs of every single action performed across your entire data ecosystem. Whenever a user queries a table, changes a permission, or attempts to access restricted data, that action is permanently recorded with a timestamp and the user's identity. These audit logs are an absolute requirement for companies operating in highly regulated industries like healthcare or finance, ensuring everyone is held accountable for their actions. Knowing that Unity Catalog provides comprehensive audit logging by default is a great fact to remember for situational exam questions. If you ever need to quickly look up information about your tables, columns, or current user permissions, Unity Catalog provides a built-in feature called the information schema. The information schema is simply a collection of system-managed, read-only tables that contain the complete metadata of your entire catalog. By writing standard SQL queries against the information schema, you can easily generate a list of every single table you own or check exactly who has access to your sensitive datasets. The exam will definitely check if you know that the information schema is the primary tool for querying system metadata programmatically. As Databricks continues to push the industry forward, they are heavily encouraging all customers to upgrade their legacy Hive metastores into the modern Unity Catalog environment. To make this transition easier, Databricks provides an automated upgrade wizard and a specific sync command to quickly convert old tables into the new 3-level namespace format. While you do not need to memorize every single step of the upgrade process, you should definitely know that tools exist to seamlessly migrate legacy data into Unity Catalog without causing downtime. To quickly summarize this critical security section, you now understand how Unity Catalog provides centralized governance across all of your Databricks workspaces. You learned the required 3-level namespace, the massive differences between managed and external tables, and how to control access using standard SQL grants. We also explored how storage credentials secure cloud access, and how automated data lineage makes troubleshooting your pipelines easier than ever before. These governance concepts represent a very large portion of the exam blueprint, making this knowledge absolutely vital for your success. Congratulations on successfully completing the 5th section of this course. Your dedication to mastering these complex security topics is truly impressive. Now that you strongly understand Unity Catalog, I highly encourage you to complete the attached practice test for this specific section. Answering these practice questions will solidify your knowledge of the 3-level namespace and external tables, greatly improving your overall exam readiness. The practice test is included right here with this lesson, so please take a few minutes to actively test your new skills. Finish this section strong, and I will see you in our final section where we master Databricks workflows and SQL. Welcome to the 6th and final section of our Databricks Certified Data Engineer Associate Exam Preparation course, where we bring everything together using Databricks workflows and Databricks SQL. In this lesson, you will learn how to orchestrate complex, automated data pipelines and how to serve that pristine data directly to business analysts. This topic is incredibly important because a data pipeline is only useful if it runs reliably on a schedule and actually delivers visible value to the company. Get ready to master the final pieces of the Lakehouse puzzle, because by the end of this video, you will be completely prepared to tackle the orchestration and querying questions on your certification exam. Up to this point in the course, we have manually triggered our notebooks and pipelines by clicking the Run button ourselves. However, In a real enterprise environment, data engineers use a powerful tool called Databricks Workflows to fully automate these processes. Workflows is a fully managed orchestration service that allows you to schedule, run, and monitor complex data pipelines without needing any external third-party tools. For the exam, remember that Workflows is the native, built-in solution for automating your entire medallion architecture directly inside the Databricks workspace. The fundamental building block of a Databricks workflow is called a job, which is simply a collection of one or more tasks. A task is a single, specific unit of work, and the absolute beauty of workflows is that a task can be almost anything. You can create a task that runs a Python notebook, a task that executes a Delta Live Tables pipeline, or even a task that runs a standard SQL script. The exam will expect you to know that workflows can seamlessly stitch together entirely different types of workloads into one unified, automated process. When a job contains multiple tasks, you can easily define the exact order in which they must execute by setting up task dependencies. This means you can tell the workflow to run your autoloader ingestion task first, wait for it to completely finish, and only then start the data quality testing task. Just like Delta Live Tables, Workflows provides a beautiful, interactive visual graph that shows exactly how your tasks are connected and running in real time. Understanding how to link tasks together sequentially or run them in parallel is a core concept you will be tested on. Once your job is fully configured, you need to decide exactly when it should run by setting up a schedule. Databricks Workflows supports standard scheduling options, allowing you to easily run jobs every hour, once a day, or on specific days of the week using traditional cron syntax. You can also trigger jobs continuously, where a new run starts immediately after the previous one finishes, which is perfect for near real-time requirements. The exam will definitely verify your ability to choose the correct scheduling method based on specific business freshness requirements. When configuring a job, you must also select the type of compute cluster that will actually execute the physical work. As we discussed in the very first section, you should absolutely always choose an automated job cluster rather than a highly expensive interactive cluster. When a scheduled workflow uses a job cluster, Databricks spins up the servers, runs your code, and immediately terminates the cluster the exact second the job finishes. The certification exam frequently tests your knowledge of cluster economics, so always remember that job clusters are the most cost-effective choice for automated workflows. In complex pipelines, you often need to pass information from one task to another, such as passing a dynamically generated date or a calculated record count. Workflows handles this beautifully using a feature called task values, which allows a completed task to easily share small pieces of data with the tasks running after it. For example, your first task could calculate the total number of new customers today, and safely pass that exact number to a later task that updates a dashboard. Knowing that task values enable seamless communication between isolated steps in your pipeline is a fantastic exam tip. Because cloud environments can sometimes experience random network glitches, a good data engineer must always plan for failure. Databricks Workflows allows you to easily configure automatic retry policies for every single task in your job. If a task fails because of a brief network timeout, the workflow will simply wait a few minutes and try running it again before sending out a massive panic alert to the team. The exam will expect you to know that setting up intelligent retry policies is the best way to build highly resilient, self-healing data pipelines. Even with retries, a pipeline might eventually fail completely, and your engineering team needs to know immediately. Workflows includes a robust, built-in notification system that can automatically send alerts when a job starts, succeeds, fails, or takes much longer than expected. You can easily configure these alerts to send a standard email to your team, or send a direct message to a Slack or Microsoft Teams channel using webhooks. Understanding how to monitor pipeline health and configure automated failure notifications is a required skill for the certification. Once your automated workflows have successfully processed and cleaned the data, that pristine data needs to be served to business users. This is where Databricks SQL comes into play, providing a dedicated, simplified workspace designed specifically for data analysts and business intelligence professionals. Instead of writing complex Python code in notebooks, users in Databricks SQL focus entirely on writing standard SQL queries to explore the gold layer of your lakehouse. The exam will ensure you know that Databricks SQL is the ultimate destination for ad hoc querying and data visualization. The compute engine that powers Databricks SQL is entirely different from standard Spark clusters, and it is known as SQL Warehouse. SQL warehouses are highly optimized specifically for running hundreds of small, rapid-fire SQL queries concurrently, rather than processing massive, heavy data engineering workloads. They automatically scale up when dozens of analysts log in on a Monday morning, and automatically scale down when everyone goes home. Knowing that SQL warehouses are the specific compute resources used to power Databricks SQL is essentially guaranteed to appear on your test. To make Databricks SQL even faster, Databricks introduced a massive architectural upgrade known as serverless SQL warehouses. In the past, when an analyst wanted to run a query, they often had to wait 5 or 10 minutes for the cloud provider to boot up the servers. With serverless SQL warehouses, the compute capacity is constantly kept warm in the background by Databricks, meaning queries start running in less than a single second. The exam heavily favors serverless compute because it completely eliminates frustrating startup times and requires zero infrastructure management. Inside the Databricks SQL workspace, analysts can easily write SQL queries, execute them, and instantly turn the results into beautiful visual charts. With just a few simple clicks, a table of raw sales numbers can be transformed into a bar chart, a scatter plot, or a geographic map. This built-in visualization capability means business users do not always need expensive external tools to quickly understand their data. The certification exam will verify your understanding that Databricks SQL has native data visualization features built right into the browser. Once an analyst has created several useful charts, they can easily combine them into a single, interactive dashboard. Dashboards allow business leaders to see a unified, high-level view of company performance, and they can be securely shared across the entire organization using Unity Catalog permissions. Furthermore, dashboards can be scheduled to automatically refresh their data every morning, ensuring the executives are always looking at the absolute most current metrics. The exam wants you to know that creating and sharing scheduled dashboards is a primary use case for Databricks SQL. Another incredibly powerful feature inside Databricks SQL is the ability to create automated data alerts based on specific business conditions. For example, a business analyst can write a query that checks daily revenue and set an alert to automatically trigger if that revenue ever drops below a certain threshold. When the alert triggers, it can instantly notify the sales team via email or a custom webhook, allowing them to react to the problem immediately. Knowing how to differentiate between a workflow failure notification and a Databricks SQL business alert is a very common exam scenario. To ensure dashboards load as fast as possible, Databricks SQL relies heavily on an intelligent feature called query history and caching. When an analyst runs a complex query, the system temporarily saves the exact results in a high-speed cache. If another analyst runs that exact same query 5 minutes later, Databricks SQL completely skips the heavy processing and instantly returns the cached result. The exam will definitely expect you to understand that caching is the primary mechanism Databricks uses to provide lightning-fast performance for commonly used dashboards. While Databricks SQL has fantastic built-in dashboards, many large organizations already use external business intelligence tools like Power BI or Tableau. Fortunately, Databricks SQL provides highly optimized, native connectors for all of these major third-party platforms. This means a Tableau user can connect their desktop software directly to a Databricks SQL warehouse and query the lakehouse data seamlessly, without ever logging into the Databricks web interface. Knowing that Databricks perfectly integrates with the broader data ecosystem is a very important concept for the exam. As we reach the end of our technical material, take a moment to visualize how perfectly these different Databricks features work together. Autoloader incrementally streams your raw data into the bronze layer, while Delta Live Tables cleans and refines it into the gold layer. Unity Catalog sits quietly in the background, ensuring absolute security and tracking data lineage every step of the way. Finally, Databricks Workflows automates this entire medallion architecture, and Databricks SQL serves the final, pristine results to your eager business analysts. When you finally sit down to take the Databricks Certified Data Engineer Associate exam, My biggest tip is to always read the last sentence of every question very carefully. The exam loves to present a scenario and ask for the most cost-effective solution, which usually means using a job cluster or triggered mode. If they ask for the most reliable ingestion method, you should immediately look for autoloader. By paying close attention to these specific adjectives, you can easily eliminate incorrect answers and confidently select the very best architectural choice. Congratulations on successfully completing the final section of this entire certification course. Your commitment to your career and education is absolutely outstanding. Now that you understand the mechanics of workflows and Databricks SQL, I strongly encourage you to complete the final attached practice test. Practice questions are the absolute best way to improve your memory retention and verify your overall exam readiness before the big day. The complete practice test is included right here with this lesson, so please take the time to actively test your newly acquired knowledge. Thank you so much for learning with me. Keep up your positive momentum, and I wish you the absolute best of luck on your certification exam.